Imagine you're tasked with configuring a Programmable Logic Controller, or PLC, that needs to handle 8 analog inputs and 8 digital inputs, all operating at 12 volts, but without using PNP inputs. This is a specific challenge that requires careful selection and configuration. The analog inputs could be for measuring voltage, current, or temperature using RTDs, thermocouples, or thermistors. It's unlikely you'll find a single PLC unit with all these inputs built in. Instead, you'll likely need a base CPU unit and additional analog input modules to reach the required number of inputs. Understanding the types of signals your PLC can handle and how to properly connect and configure these modules is crucial. Let's dive into the specifics of what you need to consider when selecting and configuring these inputs to ensure your system operates efficiently and reliably. To understand the complexities of analog and digital inputs, let's dive into the physics behind them. Analog inputs represent continuous signals, like varying voltage levels, which can be compared to a smoothly changing dial. Digital inputs, on the other hand, operate on discrete states, either on or off, akin to a simple switch. The PLC interprets these inputs through its input modules, which convert the physical signals into data the processor can understand. For analog inputs, this involves an analog-to-digital converter, ADC, that samples the signal at regular intervals and quantizes it into digital values. Digital inputs are simpler, requiring only a threshold check to determine their state. Understanding these mechanisms is crucial because it affects how you configure and troubleshoot your PLC system. For instance, the sampling rate of the ADC can impact the accuracy of analog readings, while the debounce time for digital inputs can prevent false triggering from electrical noise. Now, let's dive into the core mechanism of selecting a PLC tailored to your specific input requirements. Imagine you need a PLC with 8 analog inputs and 8 digital inputs at 12 volts, but without PNP inputs. This is a nuanced requirement, and it's crucial to understand the differences between PNP and NPN inputs. PNP inputs source current, while NPN inputs sink it. For your needs, you'll be looking for a PLC that supports NPN inputs. Most PLCs don't come with all the required inputs in a single unit, so you'll likely need a base CPU and additional analog and digital input modules. When choosing, ensure the PLC's communication protocol and module compatibility align with your system's requirements. Also, consider the PLC's expansion capabilities for future-proofing. Let's dive into configuring and connecting PLC modules. First, you need to identify the specific modules you'll use, such as analog input or digital output modules. Once identified, consult the PLC's datasheet for pin configurations and electrical requirements. Next, power down the PLC before connecting any modules to avoid electrical damage. Use the appropriate connectors, usually screw terminals or plug-in connectors, to attach the modules. After connecting, power up the PLC and access its programming software. Navigate to the module configuration section. Here, you'll assign addresses to each module, ensuring they match the physical connections you've made. Don't forget to set the communication parameters, like baud rate and parity, to match your system's requirements. Finally, test the connections by running a simple program that reads from an input module and writes to an output module. This confirms that your PLC and modules are correctly configured and connected. Navigating the complexities of PLC configuration often leads to common challenges that can impede progress. One frequent issue is the configuration of analog inputs. For instance, setting up a PLC with 8 analog inputs and 8 digital inputs at 12 volts, but without PNP inputs, requires careful selection of compatible modules. Remember, a PLC with such specific requirements may not exist in a single unit. You might need to combine a CPU with additional analog modules. Another challenge is understanding the type of analog inputs needed, whether they are voltage, current, RTD, thermocouple, or thermistor. Misconfiguration here can lead to inaccurate readings and system failures. To troubleshoot, verify your module connections and ensure your PLC firmware is up to date. For digital inputs, confirm the correct voltage levels and signal types. If you encounter error codes, such as a communication failure, Check your cable connections and driver installations. By meticulously following these steps, you'll ensure a robust and reliable PLC configuration.